So you'll go ahead and do the factoring and the math knowledge question, and then pause the video, and when everyone finishes, y'all can play it, and I'll show you the correct answers. So 436 both divide by 4. So we're going to factor out a 4. We're going to have 100 minus 9x squared. And so this is just a difference of two squares. So it'll factor as 10 minus 3x, and then 10 plus 3x. And so that would be your factoring answer for today. Now for this one, we start by dealing with our absolute value. Negative 8 plus 9 is 1. The absolute value of that is 1. So we have negative 5 times 1. So our answer is going to be negative 5. So today we're looking at lesson 65. We're dealing with falling body problems. So hopefully after this lesson you'll understand how the falling body problems work. We have an object dropped from a height of 2,000 meters. Begin with the acceleration function and develop the position function. How far above the earth will the object be 20 seconds later? So this one says, begin with the acceleration function and develop the position function. I know that some of you may be able to go straight to the position function, but we are going to practice actually developing it. So our acceleration function in calculus, we use negative 9.8 for our gravity. So that's our acceleration function. To go to velocity, we're going to integrate that. So if you integrate a of t, which is negative 9.8, you're going to end up with your velocity function, which is going to be negative 9.8t, and you do have a plus c because you integrated. And so what we need to do now is figure out the c. And so it says that it was dropped, so that means at time of 0, the velocity is 0. So whenever I plug in a 0 for my time, my velocity is going to equal 0. So that means that my c equals 0. So therefore, my velocity function is just negative 9.8t. And now we're going to integrate that to get to our position function. So the integration of the velocity, which is negative 9.8t, is going to go to the position function, which you can use as an x of t, or you can make it h of t, whichever one you want. But if you integrate that, you're going to get negative 4.9 t squared and then plus c. And now it tells us that the height is 2,000 when the time is 0. So if you plug in a 0, you end up getting 2,000 for your c. So that tells us that the height function is negative 4.9 t squared plus 2,000. So then, that was the whole the position function right there. So this is part of our answer. And then it says, how far above the earth will the object be 20 seconds later? Well, how far above the earth is talking about a position, the height above the earth. So our height function, we're going to plug in 20 for our time. And so we have negative 4.9. Instead of t, we're going to put 20 because that's the time that we are concerned with. And then plus 2,000. So if you use your calculator, you end up getting the height at 20 seconds is 40 meters. And so that would be your answer there. Okay. Looking at the next one. A ball is thrown downward with a velocity of 400 meters per second from a height of 2,000 meters. Begin with the acceleration function and develop the position function for the ball. What will be the position of the ball after 8 seconds? So again, we're going to start with the fact that our acceleration function is negative 9.8. Remember, it's negative 9.8 in calculus. You don't use negative 9.81 like you do in physics. So we're going to integrate negative 9.8, and we will get negative 9.8t plus c. So that's our velocity function, negative 9.8t plus c. So then it tells us, at time of 0, the velocity is 40 meters per second. Now, it's thrown downward. When it's thrown downward, that means that the velocity is a negative. So negative 40 equals negative 9.80 is our time because we're looking at the beginning of the problem. And so that tells us that our C is negative 40. So our velocity function is negative 9.8 t minus 40. Now we integrate that and your variable of integration is a t. And if you integrate that, that'll give you your height function, which is negative 4.9 t squared minus 40t, and then don't forget your plus c. And then it tells us the height originally was 2,000. So when our time is 0, our height is 2,000. And so if you plug in your 0, you end up getting 2,000 for your c. So that means that your height function is negative 4.9 t squared minus 40t plus 2,000. And so there's your height function. That was the whole development. And now it asks for the position of the ball after 8 seconds. So we plug it into our height function. And the height at 8 seconds, if you plug that into your calculator, you should get 1,366.4 meters. And so that would be your height at 8 seconds, your position at 8 seconds. Okay, let's look at another one. A boy stood on top of a building 40 meters high and threw a stone so that it had an initial upward velocity of 20 meters per second. This whole upward, downward velocity, that does make a difference because it changes whether it's a positive or a negative. Begin with the acceleration function, develop the velocity and the position function for the stone, and then it asks us how high will the stone go and how long after the stone is thrown before it hits the ground. So we're going to start with our acceleration, which is negative 9.8. And if you integrate negative 9.8 with respect to t, you get your velocity function, which is negative 9.8t plus c. Now it told us it had an initial upward velocity of positive 20 when our time was 0. So that means that our c is 20, and so our velocity function is negative 9.8t plus 20. Now we're going to integrate that. So the integration of negative 9.8t plus 20 with respect to t, that's going to be our position function, which is negative 4.9 t squared plus 20t and then plus c. And it says, looking back up here, a boy stood on top of a building 40 meters high. So our height here is 40, and our time is 0, because that was at the very beginning of the problem. So that means that our c has to be 40. So our height function is negative 4.9 t squared plus 20t and then plus 40. So that's your height function there. And it asks, how high will the stone go? Move this over here. The height of the stone, how would we figure that out? Well, we want to know when the velocity is equal to 0, because we're standing on a building here. There's a little man, and he throws it up, it hits a peak here, and then it hits the ground down here, and it slats. What we're looking for is that height there. So in order to find that, we need to figure out when is the velocity equal to 0. So if you look here, our velocity function is negative 9.8t plus 20. And so we're going to set it equal to 0. So 9.8 t equals 20. So 20 divided by 9.8, we get 2.0408 seconds. So this is the time that it reaches the max height. But that's not our actual answer. We need that number, and we plug it into the height function. And so if you plug that into the height function down here, that'll give you the max height for this function. And so you should get 60.4082 meters. And so this is your actual answer here for how high will the stone go. So we figured out at the time that it'll be at the height, and then we plugged it in the height function. Now the second one says, how long after the stone is thrown will it hit the ground? So we want to know, when is the height equal to 0? Well, in order to do that, we're just going to set our height function equal to 0. So when does this equal 0? Well, we've got a quadratic, so we're going to use the quadratic formula. So t equals negative 20 plus or minus the square root of 20 squared minus 4a is negative 4.9, and our c is 40. And then all over 2 times negative 4.9. And so we're going to plug that into our calculator, and you should get two numbers. One of them is going to be a negative number, negative 1.4703. And then the other is going to be the positive number, and it's going to be 5.5520. Now the negative number is not the one that we're going to use. If you had continued the parabola going this way and the ball had hit back here, that would be where the negative number came from, which is technically impossible, but that's what the math gives us. So we only use the positive number, and so it's 5.5520 seconds. That is how long it will take our ball to hit the ground. And so you only want to use the positive for your time, just like we've done in physics. Okay? So your homework is due tomorrow. There are none to omit, so make sure to do those so that we can go over any questions that you have tomorrow.